My name is Higgs and this is my friend Bozan. Welcome to the Higgs world.
Thanks for the introduction, Higgs. In this presentation, our goal is to offer you a quick summary of the research and conclusions. We follow inquiry-based learning model where students take lead in learning.
First, they get a quick review of the research via the videos. Second, they review the paper to learn and understand key concepts. Finally, they can follow up with further research on their own to dig deeper. In the end, students would have learned something new, latest and relevant. Isn't that wonderful, Bozan?
Great point, Higgs. Please follow the links to review the research in further details. We want to thank all the authors and publishers for making this research public, thereby advancing science and innovation. Please like, share and subscribe.
Today, we are reviewing a paper titled, Formation of Contractile 3D Bovine Muscle Tissue for Construction of Millimeter-Thick Cultured Steak. The global consumption of meat is increasing with population growth, leading to concerns of a future protein crisis. As the conventional livestock industries have been problematic for sustainability due to the ethical problems and its adverse effects on the environment, more sustainable technologies for meat production are required to bridge the demand-supply gap and thwart the protein crisis. Cultured meat constructed via tissue culture of animal cells is one of the promising candidates as sustainable next-generation meat, as it can be generated using small amounts of cells obtained without killing livestock, as well as lower land use and water footprint.
That is wonderful information, Higgs. Cultured meat has been constructed using 3D culture methods developed in the fields of regenerative medicine and drug discovery. For the construction of cultured steak meat with a realistic texture, large muscle tissue with densely accumulated and unidirectionally aligned matured myotubes is required. Current methods result in isotropic distribution of myotubes, low density and loss of contractility. Hence, methods for construction of bovine muscle tissues that can be used as steak meat are still challenging. In this study, the researchers develop a culture method for constructing 3D cultured bovine muscle tissue, composed of unidirectionally aligned myotubes sufficiently mature to show contractility.
That is so intriguing, Bozan. To establish the construction method, the researchers clarify the composition of the hydrogel covering the myocytes during culture and the effects of applying electrical stimulation to the tissue. They also develop a method for fabricating millimeter-thick bovine muscle tissues containing highly aligned myotubes using bovine myoblast-laden hydrogel modules with striped structures.
What is interesting about this analysis is the following. To assess the difference in texture between the cultured millimeter-thick bovine muscle tissue and commercially available steak, the researchers measured their breaking force as an index of stiffness for food. The results showed that the cultured millimeter-thick bovine muscle tissue hardened with culturing, indicating that the morphological changes accompanying the culture affected the stiffness of the cultured tissue. One of the advantages of the millimeter-thick bovine muscle tissue as cultured steak meat over commercial meat is its sterility, owing to control over the culture environment.
Great point, Bozan. The researchers evaluated the microbial contamination of the muscle tissue to confirm this. Results of the general viable bacteria test showed that the amount of general bacteria in the muscle tissue cultured for 14 days was below the detection limit.
That is a very important observation. The research proposes that the bovine muscle tissue possesses appropriate physiological properties and food characteristics of meat. The researchers believe that the proposed method for construction of bovine muscle tissues will be useful for producing cultured steak meat on a large scale. The researchers believe that further maturation of bovine muscle tissue may be facilitated by optimizing the electrical pulses. Further work needs to be done for the substitution of materials to form bovine muscle tissue from edible materials.
Finally, using the method proposed, the cultured bovine muscle tissue can be easily enlarged by increasing the number of stacked modules, leading to the formation of bovine muscle tissue of standard size for steak meat. 3D bioprinting technology may have the potential to automate the mass production of stacked modules. That was an interesting paper. Hope you liked it. Please follow the links to review the research in further details. Please like, share and subscribe.